So hopefully you remember, as we were just talking about a minute or two ago and 3 months ago, that our integral of a function normally finds us the area between that function and the x-axis, right? And if you remember back way back to when you were in, like 3rd grade, and they told you to find the average of something, right? Like they said, okay, find the average. I don't know. They probably said like find the average height of everybody in the class, and they measured everybody because they were like all about doing this hands-on learning, and they measured everybody and said, each person was a certain number of inches tall, and then they said find the average height, and you added together all the heights and you divided by the number of people in the class, and you got an average number of inches that each person was in the class. Remember doing that?
Sure.
Yeah, sure, something like that. Or you said, let's find the average temperature today. And the teacher said, all right. And they called one person every 15 minutes to go outside and see what the thermometer outside said, what the temperature was. And you'd go outside and you look at the temperature, and you'd come back in and you tell the teacher the temperature, and they'd write it down. And then you do that, and you got a bunch of different temperatures every 15 minutes the whole school day. And the end of the school day, you added them all up and divided by the number of times each kid went out there and checked the temperature, and you got an average temperature for the day. True? That sound about right?
Yeah.
Well, the average height thing is fine, right? The average height, yeah, I mean, that's okay. But what about the average temperature? Is that really the average temperature for the day? Or for that time, that part of the day?
No.
No. Good answer. Yeah, it's not really, right? It's just an average of a set of data points that you were given. Right? It's not an actual average temperature, because the temperature fluctuates throughout the day, doesn't it? Right? It's continuously changing, right? With minor, small fluctuations. Or, perhaps at 1 o'clock it was 75 degrees, and at 1:15 it was 76 degrees. But during that time period, the wind picked up between 1 and 1:15. The wind picked up and the sun went behind the cloud, and it got really cold for like a few minutes, and it dropped from 75 to 70 and then back up to the 76 because the sun came out from behind the clouds. Well, none of that's getting taken into account, right? This is a continuously changing function. And in calculus and in much of the higher math that you want to take in life, you will sometimes be asked to find the average value of a function that is continuously changing. So the average value of any function, like we might want to find the average value of a parabola, or we might want to find the average value of a cubic function on an interval, or of the sine curve, or of some continuously changing function, not just from a set of data points. And so there's a distinct difference between the average value of some points and the average value of an infinite number of those points on a continuous function. You guys see the distinction there?
Yes.
Oh, good. So we define the average value of a continuous function as some value, we usually call it h, but you can use any letter to represent it, such that if I were to take a rectangle with a width of b minus a and a height of h and find its area, this area of this rectangle made from b minus a times h would be equal to the exact area underneath the continuous function that I'm looking at from a to b. And that's how we define the average value of a continuous function. So what we're basically saying here is, to find the average value of a continuous function, we want the blue area to equal the red area. And what's the blue area? How do I find that? What is the representation of that, assuming this is the function f of x here for both of these?
The integral of f of x.
From a to b. Oh, I wrote an equals sign there. Right? We want that to equal this. And what is the area of the red rectangle? It's the base times the height. And what's the base?
B minus a.
B minus a, and the height is just h. And so since h is the actual average value of this continuous function, we want to solve for that, which means that the average value of a continuous function is what? The integral divided by b minus a, or if we wanted to, we could put that as a constant out in front, 1 over b minus a times the integral from a to b of f of x dx. Good or no?
Good.
Okay. Now, this is not to be confused with the average rate of change on the interval, because oftentimes people mix up average value and average rate of change. Right? An average rate of change is just a slope. Right? The average value is this formula right here. And so we're going to apply this formula, which is what we call the mean value theorem for integrals, and try to find the average value of some continuous functions on some interval. Easy enough?
Yeah.
And so in doing this, we'll be able to review a little bit of how to find our integrals. So there it is. There's the value. H is what we were calling this before, or h is f of c, right? And we're guaranteed, according to this theorem, that we can find that average value. It will appear somewhere on the interval between a and b. Guaranteed. So if I go back, we'll note that somewhere in here at C is where we hit H, where we actually hit the average value. We will always hit the average value somewhere. Okay? So we want to find the average value of f of x equals 4 minus x squared on the interval from 0 to 3. So how should we set this up?
Just plug in the values.
1 over what?
3 minus 0.
Times the integral from 0 to 3. 4 minus x squared dx. And hopefully we can do 3 minus 0. And hopefully we remember how to integrate 4 minus x squared. Integral of 4 is?
4x.
And the integral of minus x squared is?
1/3 x cubed.
Cubed over 3, right? The power rule. Go up a power, divide by the new power. And this is a definite integral, right? Because we're evaluating it from a to b. So how do we do that? Well, we put our 1/3 out in front still, and then we evaluate it at 3. 4 times 3 minus 3 cubed over 3. And then we subtract whatever you get when you evaluate it at 0, which in this case is 0. So what do we have here? We have 1/3 of 12 minus 27 over 3. We get 1/3 of 3, or 1. So the average value of the parabola 4 minus x squared between x equals 0 and x equals 3 is 1. And if, just for fun, we can look at 4 minus x squared, right? There it is. From 0 to 3, we got some values up here, we got some values down here. The average value that we're at, if I were to take every single one of the points this in here, all of those infinite number of points, the average value that we would get would be 1. Good or no?
That's good.
Wonderful. And then our question also asks us, does f take on this value somewhere on this interval? And the answer is yes, it should, and we should be able to figure out when does 4 minus x squared equal 1, right? When does 4 minus x squared equal 1? Just plug it in. Tells us that x squared equals 3, or that x is equal to plus or minus root 3, and which one of those falls on the interval from 0 to 3?
Positive.
Positive.
Mm-hmm. And there we go. Everybody good there? Any questions with that?
No.
All right, and we'll note this only works for functions that are continuous on the interval. So this function was continuous. It's a polynomial. It's continuous for all real numbers, so it must be continuous on 0 to 3. All right, let's do another one. So let's see if we can find the average value of 1 over x on the interval from e to 2e. So how should we start? First off, is this function continuous for all real numbers, 1 over x?
No.
No, but it is continuous for negative infinity to 0 and for 0 to infinity. And e to 2e is on that 0 to infinity part, right?
Yep.
So it is continuous on this interval. So we'll start off with 1 over what?
2e minus e.
C, an integral from e to 2e of 1 over x dx. And what's 2e minus e?
E.
E. And what's the integral of 1 over x?
Natural log of the absolute value of x.
Oh, good. Somebody remembers their rules. Natural log absolute value of x from e to 2e. And so what do we have? We have 1 over e times natural log 2e minus natural log e. And natural log of 2e, what is that if we evaluate that out? Like you could use log rules, right? Natural log of 2 times e is the natural log of 2 plus the natural log of e. And natural log of e and natural log of e, those one's positive, one's negative, they'll cancel each other out. They're both 1, right? 1, negative 1, but they cancel each other out. So we get an average value of natural log of 2 divided by e. Good or no?
Good.
Good.
Great. All right. And it does ask find all values at which it obtains this. So when does it hit this value? It tells us that we need to set our function 1 over x equal to natural log of 2 over e, which tells us that this occurs at x equals, I'll just take the reciprocal of both, right? E over ln 2. This is the average value. It occurs at x equals e over ln 2. Good or no?
Good.
Wonderful. All right. Now, let's go back to 3rd grade and our temperature problem. See if we can remember some other stuff. So, we've measured the temperature every hour from noon until midnight and recorded the values in the table. So, if we go from noon to midnight, we got 13 different values, right? 13 different temperatures there. We want to find the average temperature in the 12-hour period, assuming that this is a continuous function. Now, we don't have a function to model it with, but we do have some approximation methods to approximate what the integral is equal to. And so we could use a left, a right, or a midpoint rectangular approximation, or we could use the trapezoidal rule. And I specifically asked you here to use the trapezoidal rule. So we'll use the trapezoidal rule to approximate this integral. So we're going from t equals 0 to t equals 12. So what should go out in front? 1 over what?
Minus 0.
0 times an integral from 0 to 12. We'll call it, what do I call it? Capital T of x dx. And we're going to, like we said, approximate this using the trapezoidal rule. And so we've got 1/12. And what does the trapezoidal rule say? It says, hopefully you remember it. Anybody? No?
The y values?
Got to do with the y value. True, but there's a coefficient out in front. It's b minus a, ending minus starting, divided by the number of subintervals, divided by 2. And then it's the first y value plus what?
2 times the next y value.
2 times the next one plus 2 times the next one, and so on. So you get to 2 times the second to last one, and then just the last one. Good or no? So really, we've got 1 over 24 times this. And you guys have calculators. You can tell me what that comes out to be. Anybody?
I got 59 and a half.
You got what?
59 and a half.
59.5?
Yes.
Exactly 59.5?
Yes.
Anybody agree with that? That seems a little low to
I
me.
got 65.16 repeating. I don't know if that's right though.
I got the same thing.
65.16 repeating. Yeah, a couple different. All right, I'm going to go with that one because I got at least 3 different people that got that. I think you probably just missed multiplying something by 2 or missed something ever so slightly the other way. Got it. Missed one value or something. Any questions on that? Everybody okay with that? Makes sense. Feel all right? Yes, no, maybe.
Yeah, just the trapezoidal rule. Didn't remember that one.
Ah, yeah. I got to remember those rules. They're going to show up on the AP test. We'll review them all eventually through the multiple choice and through our free response questions, but got to know those rules. In fact, what I will be doing at some point in the relatively near future is I'll be giving out sort of like a typed up document of all the things that you should know for the AP test, all written out. And so you'll have that to take a look at and study with. Prepare yourself better. I got to finish it up though. It's not quite done yet. So good or no? Everybody okay? Not okay? Sort of okay?
So when we find the h value, why do we set the equation equal to h?
Well, just because in the previous ones it asked us to. So it said find the mean value and then find all values at which it obtains that. So this is the value which it hit it. Same thing here. It just said, does f actually take it on at some point on the interval? Yeah, it does at x equals √3. Only because it won't always ask you to, but I feel like it's good practice to find it if we need to.
Okay.
Yep. All right. I think we should do another problem or so, just to practice some of our integrals. So let's find the average value of, what's a good function here? How about the average value of f of x equals the sine of 3x from x equals 0 to x equals pi over 4. How's that sound? Let's see how well we remember how to do math. You guys want to work on this one on your own? See if you could do this one on your own for a minute, and then we'll go through it together. All right. I think that'll be good. I'll put a few extras up here after, we'll do 2 or 3 extras just to practice some of our integrals, because I think that'll be good for us. So, all right, I'm gonna give you guys 2 minutes to try and work that out. Ready, go. So we're finding the average value of sine 3x from 0 to pi over 4. We need to do 1 over b minus a, so that's 1 over pi over 4 minus 0. And then we have to do a u substitution. So we let u equal 3x, which tells us that du is 3 dx. So we put a 3 on the inside and cancel it out with a 1/3 on the outside. And then we rewrite our constant out in front. The 1 over pi over 4 is 4 over pi times the 1/3 is 4 over 3 pi. And then we change the inside, our integrand, to sine u du, because we have 3 dx, which is du, and we have sine of 3x, which is sine of u. We have to change the limits of integration because we did a u substitution, which is 3 times 0 gives us 0 for the lower limit, and 3 times pi over 4 gives us 3 pi over 4 for the upper limit. The integral of sine u is negative cosine u, so we do 4 over 3 pi times negative cosine u from 0 to 3 pi over 4. And expand that out using the second part of the fundamental theorem of calculus. Cosine of 3 pi over 4 is negative √2 over 2, so the negative cosine of it is positive √2 over 2. And then minus negative becomes plus cosine 0 or plus 1. And if you distribute it through, you get 2 √2 plus 4 all over 3 pi, or 2 separate fractions if you want, or you don't need to bother distributing it. So first off, we want the average value from 0 to 1. So it should be 1 over b minus a times the integral from a to b of our function. Everybody hopefully got that set up?
Yes.
Okay. Conveniently, this just ends up being a 1 out in front, so we can ignore that. And what's the integral of 1 over 1 plus x squared?
Tangent.
Inverse tangent, right? Inverse tangent of x plus x squared over 2. And so all we need to do is evaluate that from 0 to 1. So this is inverse tangent of 1 plus 1/2 minus inverse tangent of 0 plus 0. And what's the inverse tangent of 1?
Pi over 4.
Pi over 4 and plus 1/2. And what's the inverse tangent of 0?
0.
Plus 0 is still 0. So we just get pi over 4 plus 1/2. Good or no? Do we have any questions or issues with that one?
Nope.
All right. I guess let's do one more and then we call it good for today. Let's find the average value of, how about, how about f of x equals 2x plus, what is it? 2x plus x over root 1 minus x squared on the interval from, how about, 1/2 to root 3 over 2. That seems good. Let's do that. All right, ready to go. I'll give you 3 or 4 minutes on this one. It's a little more difficult. All right, so we should have had 1 over root 3 over 2 minus 1 over 2 times an integral from 1/2 to root 3 over 2. And then 2x plus x over root 1 minus x squared dx. Everybody get that set up? I hope.
Yeah.
Okay. So the root 3 over 2 minus the 1 over the 2, the 1 over that, we could flip it and make that 2 over root 3 minus 1. And then we've got an integral of 2x dx, which should be really easy to do. But the other one is a little more complicated. I'm going to write them as separate integrals, remembering that we can write them as separate integrals. So that we can more easily evaluate this. So the first one becomes what?
X squared.
Yeah, and note that that 2 over root 3 minus 1 goes to both of those. So we got the 2 over root 3 minus 1 times x squared from 1/2 to root 3 over 2. And then plus, how are we going to integrate the second one?
Can you pull out an X?
Okay, we can't pull the x out, unfortunately. But what we can do is we can rewrite this in terms of u, and let u equal 1 minus x squared, which gives us du equals what? Negative
2x.
Yeah. So we're going to put in a negative 2 and a negative 1/2. So get rid of that. Should have given you some better values for this probably, but we'll have minus 1/2 here. And now it becomes an integral of the negative 2x dx will become du. And then this will become u to the negative 1/2. And instead of integrating from 1/2 we'll integrate from 1 minus a half squared, which will be 3/4. And then root 3 over 2, that becomes 3/4, right? When you square it, and 1 minus 3/4 is 1/4. Good or no? And that's a little bit of a mess. 2 over root 3 minus 1. X squared, if we evaluate that at root 3 over 2, is what, 3/4? Minus 1/4. And now we've got, let's see, this integral here, we could flip the limits, right? And change this from a negative to a positive. That was one of our rules. So we could have plus 1/2. And what's the integral of u to the negative 1/2? That should be 2 root u. And since we flipped the limits by making that positive, we'll make it 1/3 or 1/4 to 3/4. Good or no? Everybody good so far? Or no?
So you just basically been doing a U substitution and just carrying out like a super convoluted problem here.
Yeah, I mean, it's fairly ugly, but it's not that bad.
Yeah. Okay.
I mean, everybody good with me flipping those limits, the 1/4 and the 3/4, and making this a positive instead of a negative? I remember that was one of our integral rules.
Yeah.
Flip the limits and change the sign. Okay. So we got 2 over root 3 minus 1. We got 3/4 minus 1/4, which is 1/2. And then we've got 1/2 and the 2 cancel each other. So we just have square root of 3/4 minus the square root of 1/4. Square root of 3/4 minus square root of 1/4. And now we've got 2 over root 3 minus 1. We've got 1/2 plus root 3 over 2 minus 1/2. So we just end up with, well, let's see here, we're going to have root 3 over 2 times this. So the 2's will cancel, right? Because the 1/2 is, oops. The 1/2's already cancel, right? And so we've got 2 root 3 over 2 times that, which means the 2's will cancel. Gives us root 3 over root 3 minus 1. That's not that bad. Everybody good with that? Looks sort of familiar. Remember sort of how to do this kind of stuff? Gonna need some more practice?
Yeah, probably.
Yeah, probably. All right. We're gonna stop there since class is